Welcome to this Codevaan Explainer. Today, we are tackling a massive pain point for developers everywhere. You spent hours writing beautiful Python code, you hit run, and bam! It shatters into a million pieces the second it meets the real world. Today, we're taking that sudden, catastrophic crash and turning it into absolute control. Have you ever actually watched your Python program just suddenly crash right in front of your eyes? Seriously, it's a terrible feeling. One tiny error, just one unexpected typo from a user, can literally break your entire application if you don't know how to handle it. Exception handling is basically like having airbags in a car, you know? It stops the whole app from destroying itself on impact. So let's dive into this. Why do we even care about handling exceptions? Well, think about the stakes here. If you're building a simple calculator app and it crashes, whatever, right? It's low stakes. You're annoyed, you reopen the app, and life goes on. But what if you're writing code for, say, an MRI machine in a hospital, or the autopilot software on a commercial plane? Those are incredibly high-stakes, mission-critical environments. A crash there isn't just a minor annoyance, it is completely disastrous. Modern cars and planes are essentially computers on wheels and wings. We absolutely have to ensure our software can hit unexpected bumps in the road without just completely shutting down. To defend our code, we first need to understand our enemies. Section 1. The 3 types of errors. Now, what's really fascinating about how these errors break down is where things actually go wrong. First up, compile time errors. Honestly, these are the easy ones. You accidentally type def instead of def, and your IDE just immediately yells at you with a syntax error. You fix it right there, no big deal. Second, we've got logical errors. This is where your code runs perfectly fine, no crashes at all, but it gives you the completely wrong answer. Like calculating the factorial of 5 and getting 240 instead of 120. You really just need careful testing to catch those. But that third type, runtime errors, also known as exceptions, those are the sneaky ones. Your logic and syntax as a developer are flawless, but then some external factor ruins the whole party. A user types a letter instead of a number, or a crucial file gets deleted from their hard drive. Your app didn't actually do anything wrong, but it still crashes hard. Let me show you exactly what a real crash looks like. Here's a perfectly normal piece of code asking a user for a number and then dividing 10 by whatever they entered. If the user enters 2, we get 5. Beautiful, right? But what if they enter 0? Boom, you get a 0 division error. The whole program just immediately halts, it throws this massive ugly error block in the terminal, and it completely skips the rest of the execution. If you had code right after this meant to save data or close out a screen, it literally never runs. The app just dies on the spot. We absolutely cannot let our users break our apps that easily. We need a way to protect our execution flow from these runtime crashes. Enter Section 2, the Try Except Shield. To really wrap your head around how this works, think of this brilliant analogy from our source material. Imagine taking a young kid out to eat. If you're sitting inside a fully enclosed restaurant and the kid gets up to wander over to an empty table, you don't panic, right? It's a closed, controlled environment. That right there is your safe code. But imagine you're eating at an open-air highway dhaba right next to speeding traffic. If that kid gets up from the table, you instantly panic and grab their hand. That is a critical situation. In your Python scripts, simple variable assignments are like that enclosed restaurant. But reading a file, connecting to a database, or taking unpredictable user input, that's the highway dhaba, my friends. Those are critical statements that absolutely need active protection. So how do we hold our code's hand near that dangerous highway? We put those critical statements inside a try block. Here's the exact execution flow. First, Python will try to execute the critical code inside that block. If it works perfectly, awesome. But step 2, if an error does occur, the try block acts like a literal shield. It stops the crash immediately. Step 3, it jumps straight over to a matching except block. And finally, step 4, the rest of your program just continues safely. It doesn't die, it just handles the mistake and keeps right on moving. Let's look at another super common critical situation, the value error. This happens when a function gets an argument of the correct data type, but a totally inappropriate value. A classic scenario is asking the user for an integer, but they accidentally hit the letter T on their keyboard. If we don't put that user input inside a try block, this is the incredibly ugly terminal output your user gets slapped with. Value error, invalid literal for int with base 10. I mean, that is terrifying for an everyday end user to see. And again, it completely kills your app's execution. We have to catch this stuff. But here's where we really need to level up. Section 3, catching specific exceptions. Because we can't just catch every error and throw a generic, oops, something went wrong message. We need to be specific to actually be helpful. And this brilliantly illustrates why specific exceptions are so important. Imagine you're studying for your board exams, and your school has a doubt-solving day. If you have a math doubt, like our division by zero issue, you take it to the math teacher. If you have a science doubt, like our bad value input, you go to the science teacher. But what if you have a general problem, like someone stole your hall pass? You wouldn't ask the math teacher, you'd go to your class teacher. Well, exception handling works exactly the same way. You can and absolutely should stack multiple except blocks together. Python is pretty smart. If the try block throws a zero division error, Python scans down and jumps to the exact except block meant for it, allowing you to print something helpful like, hey, you can't divide by zero. If they type a letter, it jumps to the value error block, so you can print please enter numbers only. And at the very bottom, you can stick an exception as E as your class teacher. That's your generic catch-all for any weird, random error you didn't anticipate. It keeps your user messages super accurate and incredibly helpful. All right, let's move on to the very last piece of the exception handling puzzle. Section 4, the finally block. We've successfully stopped the crashes. But what about the mess left behind? You see, when you build complex software, your program is constantly opening up connections to the outside world. We call these resources. We're talking about things like opening a connection to a database, opening a text file on the hard drive to read it, or opening a network connection to an API. And when you're done using these resources, it is your strict responsibility as a developer to close them. If you don't, you cause severe memory leaks, and those leaks can dramatically slow down or even crash the entire system over time. So, the absolute crucial point to remember here is this. The finally block executes irrespective of whether you get an exception or not. Just think about it for a second. If you open a database inside a try block, and then a random error crashes that block halfway through, your code jumps to the except block, right? Which means your database just stays open forever. The finally block is your absolute guarantee. It is the cleanup crew that always shows up. Here is exactly how it looks in practice. You try to open data.txt. Then, underneath all your except blocks, you add a finally block where you write file.close. Now, whether the file reads perfectly or whether the user inputs bad data and triggers an exception, Python promises you that before it moves on, it will absolutely run the code in that finally block. In Python, a try block must be paired with either an except block, a finally block, or both, just to ensure things stay completely clean and secure. So ask yourself right now, are your Python programs actually ready for the real world? Exception handling is what takes your code from fragile little scripts to robust professional software that can actually survive bad user inputs and missing files. I highly encourage you to practice these try, except, and finally concepts in your very next project. Build an ATN system or a simple file reader and try to intentionally break it. Now you have the tools to ensure your Python programs will never crash unexpectedly ever again. If you found this Codevaan explainer helpful, make sure you subscribe for more practical Python and AI content. Get out there and write some truly crash-proof code. But before you do, I want you to think about this. What is the most disastrous bug hiding in your code right now, just waiting for the wrong user input to bring everything down? See you next time.